This is the title of your book, Mathematics 9 Science Group by Caravan Book House. We will cover pages 1 till 9, Unit 1, Matrices and Determinants. We will cover the topic Introduction to Matrices. Your resources are textbook, internet, cell phone, tablet. And this is the summary of your lesson, Introduction to Matrices and Types of Matrices. Now, first of all, what are today's objectives? At the end of the lesson, you people will be able to know about matrices, rows and columns of a matrix, order of a matrix, and types of matrix. First of all, what is a matrix? A rectangular array or a formation. Array means arrangement of a collection of real numbers. For example, these are real numbers. We arranged horizontally and vertically. And when after arrangement, if we enclosed by brackets, is set to form a matrix. You can see these are the entries, these are the numbers. We are arranged horizontally and vertically and enclosed them within a bracket. So this formation is called and to form a matrix. Similarly, this is also a matrix. These are entries and these entries are enclosed by these brackets. So this is another example of a matrix. So matrix is an arrangement of numbers when we arrange numbers horizontally and vertically. Real numbers used in formation of a matrix as elements of the matrix. So these are the elements of a matrix. Plural of a matrix is matrices. The matrices are denoted by capital letters A, B, C and D, M, N, whatever you want to denote as a matrix. So within the matrix we can have any entry, any number but when we want to denote matrix, they should be a capital letters. Now in the definition, as I told you that these are the arrangement horizontally and vertically. So first of all, first point is a row. What is a row? The entries presented in horizontal way are called rows. This is the example. You can see these are the entries, and if we arrange them horizontally, you can see first horizontal line, second and third. These are called rows of a matrix, and these are the elements of the matrix. How many rows are there? 1, 2 and 3. Now what is columns? The entries presented in vertical way are called columns of a matrix. You can see in this example, these are the arrangement vertically. How many columns are there? Column 1 and column 2. As in the previous example, how many rows were there? 3 rows. But how many columns are there? There are 2 columns, column 1, column 2. So keep it in your mind that rows are the horizontal entries and columns are the vertical entries in a matrix. Order of a matrix. What is an order of a matrix? As I have told you about rows and columns, so the number of rows and columns in a matrix specifies its order. For example, if we have a matrix M, his number of rows are M and number of columns are N, then what would be the order? Order would be M by N, where M shows the number of rows and N shows the number of columns. I will explain you with examples. This is a matrix. First of all, you have to count the number of rows. How many rows are there? 1, 2, 3. It means there are 3 rows which I mentioned here. And now what are n? N means number of columns. So count number of columns. 1, 2, 3 and 4. So what is n here? 4. So order of this matrix is 3 by 4, where 3 shows number of rows and 4 shows number of columns. What are rows? Horizontal entries. How many horizontal entries are there? 1, 2, 3. Similarly, this is 4 shows the number of columns. How many columns are there? 1, 2, 3 and 4. So how can you find the order of a matrix? By counting number of rows and number of columns. Similarly, next example, how many rows are there? 1 row, because these all entries are the entries in a row. But how many columns are there? 1, 2, 3, 4, 5. So order would be 1 by 5. 1 shows number of rows and 5 shows number of columns. Now your thinking time. This is a matrix. Counts its rows, counts its column and write down its order. Now equal matrices. Let A and B are two matrices, then A is set to be equal to B and denoted by A is equals to B if and only if the order of A is equals to the order of B. So first condition is these two matrices should have same order. And what is the second condition? Their corresponding entries are equal. What are corresponding entries? I will explain you with this example. This is a matrix A and this is the matrix B. What are corresponding entries? This is the first element. Its corresponding element is this, because this is also the first element of matrix B. Similarly, this is the third element of this matrix. And what is the corresponding element of this element is this. Similarly, the corresponding element of 7 is 7, because this is the last elements of matrix A and this is also the last elements of matrix B. You can see that all the entries are same, and this example is satisfying both the condition. First condition was order should be same. Its order is 3 by 3. Its order is also 3 by 3 and their corresponding entries are also equal. So we can say A is equals to B. Similarly, in the second examples, first of all check the order. This is these two matrices have same order. Its order would be 1 by 3, because 1 column and 3 columns, its order is also 1 by 3. And now check the entries. You can see all the entries are same, so we can say that these two matrices are also equal matrices. Now I will explain you with this example. Again, we have to satisfy both the conditions. These are two matrices. First of all, check their order. Order of this matrix is 2 by 2, because 2 rows 2 columns. Same 2 by 2, 2 rows and 2 columns. It means first condition is satisfied. Now we will check the second condition, which was their corresponding entries. So is corresponding entries 1 is equals to 1, 3 is equals to 2 plus 1 is also 3. So second elements are also same. Here third element minus 4, it is also minus 4, and fourth element is 2, and 4 minus 2 is also 2. So entries, corresponding entries are also same. So we can say these two triangles, these two matrices are equal. Now this is the second example. I have explained, you will check the order, you will check the entries, and after entries you will come to know that these two matrices are not equal because their corresponding entries are not equal. Here we have -1 and here we have -4. So we can say A is not equal to B. Now we have example here. Find the value of A, B, C and D from the following equations. How? You can see here we have two matrices, and the given condition is that this matrix is equals to this. It means their corresponding elements are equal. It is given that these two matrices are equal, so we can say their corresponding elements are equal. I have shown with the arrows. You can see that these are the corresponding elements of each other. By these correspondence we can make equations. How? 2a plus b is equals to 4. So this is the first equation. From second we will get this, and from these four corresponding elements we will get these four equations. Now we will solve the equation. Now this is first equation. Take out the value of b from first equation. Now put this value of b in equation 3, and equation 3 is a minus 2b is equals to -3. By putting the value of b we will get this, and after simplification we will get 5a is equals to 5, and by solving this equation we will get the value of a. So by using the property of equal matrices we will find the value of given variables, and the first value of unknown variable is a is equals to 1. Now putting the value of a in equation 1 we will get the value of b. How? This is equation 1. Put the value of a, which is a is equals to 1, and 2 multiplied by 1 plus b is equals to 4, and after solving we will get the value of b. Similarly, we can find the value of c and d from equation 3. We will arrange and find the value of d. D is equals to 5c minus 11. Similarly, from the next equation we will equate and we will put the value of d in this equation. So 4c plus 3d, here the value of d is this. By putting the value of this d after simplifying this equation we will get 19c minus 33 is equals to 24, and after solving all these steps we will get the value of c. So now we have the values of a, b and c. Now by putting the value of c is equals to 3 in this equation we will get the value of d. So now at the end of this question we have values of all the variables. A is equals to 1, b is equals to 2, c is equals to 3 and d is equals to 4. By using this method you people will be able to solve exercise 1.1 question number 3, and we will use the property of equal matrices. First of all you will check the order and then we'll check the corresponding entries, equate the equations and find the value of unknown variables. By using all these previous concepts, this is your task 1. You people will be able to solve question number 1, question number 2 and question number 3. Now types of matrices. First type is row matrix. What is a row matrix? A matrix is said to be a row matrix if it consists of one row. You can see with this example that this matrix consists of only one row, and its order would be 1 by 3 because there are 3 columns and 1 row. Now next example, it is also a row matrix. Why? Because it consists of only one row. This is one row and its order would be 1 by 5. How many columns are there? 1, 2, 3, 4, 5, and this is called a row matrix because there is only one row. Now next is column matrix. What comes in your mind? as row metric consists of one row. Similarly, column metric consists of one column. You can see in this example one column, so its order would be 2 by 1. And in this example we also have, this is also a column matrix because it consists of one column and its order would be 3 by 1. So this is the difference between row matrix and column matrix. Now rectangular matrix. What comes in your mind when you think about rectangle? In rectangle, length and width are not same. Similarly, you can link with rectangular matrix as we deal with columns and rows. So what is rectangular matrix? A matrix is said to be a rectangular matrix if number of rows is not equal to number of columns. This is an example. How many rows are there? 1, 2, 3, 4. And how many columns are there? 1, 2, 3, 4, 5. First of all, write its order 4 by 5. It means this is a rectangular matrix because number of rows is not equal to number of columns. Similarly, what is a square matrix? As we know, what is a square? All the four sides are equal. It means the number of rows would be equal to number of columns in a square matrix. You can see here we have this example. Here how many rows are there and how many columns are there? Here is its order 2 by 2. It means this is a square matrix because number of columns are equal to number of rows. Similarly, this is also 3 by 3 matrix because we have 3 columns and 3 rows here. So these two are the examples of square matrix. Now null or zero matrix. What is null or zero matrix? A matrix is said to be a null matrix if each of its entries is 0. These are the examples of null or zero matrix. You can see this is a matrix of order 1 by 1. Its all entries are zeros. This is the matrix of order 2 by 2 and this is the matrix of order 3 by 3. All the entries are 0. So these matrices are null matrices. Now negative of a matrix, let A be a matrix, then its negative minus A is obtained by changing the signs of all the entries of A. I will explain you with examples. This is the matrix A. All the entries have positive sign. So in minus A we will get, as these are positive, all the entries would become negative because in definitions all the signs would be changed. So negative A will be obtained by changing the signs of all the entries. Now in the next examples you can see first this element and this element are negative, as in definition signs would be changed by obtaining a minus A. So these two negative entries would become positive and these two positive entries would become negative. It means negative of a matrix can be obtained by changing the signs of original entries. Now diagonal matrix. What is a diagonal matrix? A matrix is called a diagonal matrix if its diagonal values are non-zero and non-diagonal values are 0. So look at these examples. In first example, in first matrix, you can see this is a diagonal and diagonal values are non-zero. Similarly, in this example, this is the diagonal of this matrix and the entries are non-zero. But you can observe that these are non-diagonal values and these are 0. If diagonal is non-zero and non-diagonal values are 0, then we can say these are diagonal matrices. So identification of diagonal matrix is important. You have to identify the diagonal. If diagonal is non-zero, it means it is a diagonal matrix. Now scalar matrix. How can you link diagonal matrix with scalar matrix? A matrix is called a scalar matrix if its diagonal values are same and non-zero. You can observe in these two examples, these are diagonal matrices, but what is important point? That their diagonal entries are same. In this example, diagonal entries are 3, In this example, diagonal entries are same, and what are the same value? Value is 5. So this is the difference between diagonal matrix and scalar matrix. Any matrix can be it is diagonal matrix, but if the entries are same, this diagonal matrix would become a scalar matrix. Identity or unit matrix. A matrix is called an identity or unit matrix if its all diagonal values are 1. It is denoted by capital I. You can see here we have unit matrix. You can and its order is 1 by 1 and its entry is 1. So this is an identity matrix of order 1 by 1. Here diagonal is 1. This is a diagonal matrix. Which type of diagonal matrix? Identity matrix, because in diagonal its value is, its entries are 1. This is the matrix of 3 by 3 identity matrix, because in this matrix the entries of diagonal are 1. So you can see this is the identity matrix of order 1 by 1, identity matrix of order 2 by 2. This is the identity matrix of order 3 by 3. How? Because in its diagonal the entries are 1. So this is an identity or unit matrix. Now these are some important points. The scalar matrix and identity matrix are diagonal matrix, because diagonal matrix we have mainly diagonal matrix, and how it become a scalar matrix if its diagonal have same value, and how it become an identity matrix when its identity when its diagonal values are 1. Second point is every diagonal matrix is not a scalar or identity matrix, because diagonal values can be changed. If they are same, it would be scalar. If they have 1 as entries, it would be identity matrix. Now your task number 2, you have to solve exercise number 1.2, question number 2, 1, 2, 3 and 4. So complete your assignments by doing task 1 and task 2 and submit on time by Friday. So next time with new topic and new concept. So thank you so much.